Okay, we're going to take a side step. We've been talking about the systems of the body. Specifically, we talked about the three systems that make up the kinetic chain: the nervous system, the skeletal system, and the muscular system. In different order than I went in before, but that's okay. You got the idea. You got those three systems. Before we move on to the cardiovascular system and the respiratory system and the endocrine system and all that fun stuff, we're going to look at what we call energy systems. Not really a system of the body, but it's actually how the body actually takes in takes the energy from our food and is actually converts it to usable energy for our muscles and our tissues and our various cells of the body. Once again, primarily we're concerned with muscles. So at its very root, basically what we're talking about is very, very basic biochemistry. Let's hear for biochemistry. Yeah, it's kind of what I thought. But it's not that bad, I promise. I promise it's not that bad. But it is general biochemistry. Now let's think about why this is important. Obviously, living cells, in order to stay alive, must perform work to grow, reproduce, and what have you. Hence, they must be able to harness the energy from various sources and channel that energy to do usable work to stay alive. Well, catabolism is the breakdown of molecules to release energy. So we're breaking down molecules to release energy, while anabolism synthesizes molecules, makes bigger molecules from smaller ones, using energy that was originally taken from the catabolic reaction. So catabolism is breakdown, right? While anabolism is building. So we tend to think, what do most people want to do? They want to catabolize fat and they want to anabolize muscle. But that's just two different forms of catabolism and anabolism, breakdown and buildup. But basically we're taking energy from one, breaking down, taking the energy from it and using it to build something up. That, once again, is the basics of biochemistry. So we're talking about energy. Let's talk about how we measure energy real quick. Energy is measured in our field in the form of calories. Now, what is really calories? We hear about calories in food and all the time. Well, calories by strict definition in chemistry and physics is the measurement of heat. It's a measurement of how much heat it takes to raise 1 gram of water 1 degree centigrade under standard conditions. Don't worry, you don't have to totally stress about memorizing that for any test. Just realize that calories is a measurement of energy, it's a measurement of heat. Now, when we say calories, in the strict chemistry or physics standpoint, that's what it means. The amount of heat to raise 1 gram of water 1 degree centigrade. But when we talk about food calories, no, they aren't really calories, they're really kilocalories or 1,000 calories. So that's what food label calories are, not really calories per se, they're food calories or 1,000 kilocalories. All right, 1,000 calories or kilocalories, I should say. Now, another way of measuring energy is called joules, and you might hear that as well as the SI unit for energy and work. And just because you might read or hear the term joules is just another way of measuring it. It's directly related to calories. In fact, 1 kilocalorie or 1 food calorie is equal to 4.2 kilojoules. So once again, calories and joules, two different ways of measuring the same thing. So what are the energy systems that are used in the human body to, once again, get energy to produce usable work? These are the systems that the cells of the body use to convert the chemical energy that we get from food and to a form of chemical energy that the body can use, which is ATP. And then ATP is used for often mechanical energy, to do mechanical work. Okay, so we're taking chemical energy stored in food, in our macronutrients of carbohydrates, fats, and proteins. We're taking the energy from those molecules and we're transferring it to ATP, the one usable molecule for energy for our muscles. Think of it this way. We don't actually take crude oil out of the ground and stick it straight into our gas tank, do we? No, we don't take crude oil, it has to be gasoline. We have to refine that crude oil and turn it into gasoline, right? Same thing. We don't take the energy from carbs, proteins, and fats, and they don't directly do work in our muscles. It has to be first taken from the carbs, proteins, and fat and actually transferred to ATP. So, what will we learn in this module? We're going to learn right now about how ATP is generated from 3 very distinct biochemical pathways. Okay, so our goal here is to gain more ATP, the molecule to do work in muscles. So why is energy systems, why is the understanding of energy systems important? By understanding how we get our energy, how we get our ATP, that very important molecule, we understand the benefits we're going to get out of a particular exercise. We're going to understand better about which muscle fibers are firing, about how to measure it via heart rate. We're going to understand because energy systems are connected to our heart rate is connected to the type of muscle fibers, like I already said. It's also connected to which of the fuel sources are we getting our ATP from? Are we getting it from carbohydrates, fats, or are we getting it from proteins? It's all put together, okay? We're going to be able to draw a picture now, as you can see in our little image here, of how energy systems are directly related to these other things, to the muscle fiber types, to the heart rate, to our sources of energy of carbs, proteins, and fats. They are all interrelated. When we train a particular type of athlete, a certain type of energy system will often dominate. Let's look, I keep on using the two kind of extreme examples of like a triathlete versus a mixed martial artist. A triathlete is going to use one type of energy system primarily because they're going to need kind of that long constant energy, while a mixed martial artist is going to use actually more different types of energy systems, ones that are going to have, that's going to vary because at times the fight's going to vary. At times it's going to be very explosive, other times it's going to be, you know, when they're grappling, it's going to be a different type of energy system versus when they're, you know, kind of on their feet and doing more striking and bobbing, weaving, what have you. Totally different type of energy systems than if you're in a triathlon. So when we train someone for a specific event, like a triathlon versus a mixed martial artist, we want to train the energy systems of the event. And when we train the energy systems that are used in the event, we're going to be training the right type of muscle fibers, and we'll be able to monitor it appropriately with heart rate. So that's what I mean by having it all interlinked. We want to train the proper energy systems for the goals that are specific to the goals. So that all said, let's talk about ATP again, that main little molecule. What is it? Once again, it's not motor oil. Oh, there are the crickets again. Another bad joke. Okay, it's not motor oil. It's the primary energy currency for all your muscle cells. So you've got this little molecule in there. It's made up of an adenine, which is actually a nucleic acid. It's like your DNA, basically, right? A little ribose, a little 5-carbon sugar, and 3 phosphates. Well, let's wipe that away. Forget that organic chemistry for a second. It's made up of 3 of those parts. Think of the adenine and the ribose come together and make what's called adenosine. Think of that big A there, and 3 little phosphates, PPP, right? What we're going to find is in those little bonds between the phosphates, especially the 2nd and the 3rd phosphate, the farthest 2, okay, there's lots and lots and lots of energy. And whenever a muscle cell needs to do mechanical work, what we're going to find out is the bond between the 2nd and the 3rd phosphate will split. Look at our little picture here. And it will break off. So what will happen is you'll have a DP, adenosine diphosphate. Remember, we started with triphosphate. Now we're moving to diphosphate. That little phosphate that's broken off will go off by itself, it's inorganic phosphate by itself, and lots of energy is released to do mechanical work. Now, here's the thing. We only have so much ATP stored in our muscles, and we go through it, especially high intensity, very quickly, like 2 seconds maybe, right? So really what we're talking about with energy systems is the reverse process. We need to take the ADP and inorganic phosphate and put it back together to create ATP so the muscle can do work again. So this little diagram right here is showing, once again, breaking down of ATP. In our minds, we're thinking breaking down within the muscle, but this happens in other cells too. Breaking down of ATP to do mechanical work. Well, for work to keep going, we need to form more ATP again. So we're taking those products of ADP and adding that phosphate back into it to once again create ATP. That is the whole idea of these energy systems that we're talking about, okay? So once again, as far as the ATP in the muscle, there's enough for approximately 2 to 4 seconds of activation, depending on the intensity and the exact muscle and so forth. So we've got to replenish it to keep those muscles working. Once again, it's that reverse reaction. So we're trying to replenish ATP. There's 2 broad categories and 3 distinct pathways. What do I mean by that? Well, in order to replenish ATP, You can either do it anaerobically, which means by definition without air, but really we're talking without oxygen, or aerobically, which means with oxygen, right? So for the anaerobic, we're going to learn what's called the ATP-PC system, or phosphocreatine system. That is followed by glycolysis, or breakdown of sugar. And then for the aerobic, this is what's called aerobic phosphorylation, or also called aerobic metabolism. There's a whole bunch of names meaning the same thing. So we're going to actually take that on two distinct different modules now. One, we're going to talk about the anaerobic side, and the other one, we're going to talk about the aerobic side. And what we're going to find is which energy system we're using is going to depend on number one, the intensity that's the muscles being put under, right? And also the duration. And once again, I'm going to say it again, depending on what our goals are, what are we trying to achieve, we need to base it around the energy systems. A mixed martial artist is going to train in certain energy systems, a triathlete is going to train in certain energy systems, and each energy system is going to demand different sources of fuel, be it carbohydrates, proteins, and fats. So maybe your goal is just you have someone who wants to train primarily for fat loss. Well, we'll talk about that as well and how it all relates together.